when we try to see that certain procedures have been developed in the laboratory, whether it comes to dyeing or any other technological advancement, how well is it accepted in terms of its popularity with the industry, whether the industry is happy to have this technology, or when any innovation is brought about, has it got any advantageous situation or not, is what matters. And we have seen that when we were trying to disseminate the innovative technology, it was very well accepted. Particularly, we had a big demonstration at the Swaraj Ashram, where they were into dyeing a lot of fabric, and yards of fabric are being dyed every day. So, in an organization like that, when innovative technology is introduced, how acceptable it is for that particular organization to take it up. As we go along this lecture, I will give you an overview of the innovative natural dyeing technology that was developed and then finally disseminated to the industry. The processes that were developed in the laboratory for natural dyeing consisted of innovative method of extraction of dyes. Because the problem with the industry was that they did not have good methods of extraction. They only knew one method of extraction, and that is conventional extraction. So, therefore, it was important to be able to give them some new methods of extraction, and the innovative methods of extraction that were developed were scaled up for the industrial purpose. So, efficient extraction of dye from the plant material is very important for standardization and further optimization of the vegetable dyes, and utilization of Soxhlet, conventional boiling and sonicator methods were introduced, because they had this severe mental block that they will not use natural dye because the process of extraction is very elaborate. So, we tried to break this myth, and we tried to show that within 4 hours in a Soxhlet, within 2 hours by conventional boiling, and within an hour by sonicator method, dyes can be extracted very easily from fresh plant parts or dried plant parts. So, one full exercise was dedicated to the process of extraction of natural dyes. We were in the process of popularizing natural dyeing and the use of natural dyes, because after the German ban and the Indian ban, there was a very serious condition of offering some good dyes for the dyeing industry. And as a very serious scientific exercise, we tried to bring in this innovation so that it is acceptable and doable by the industry. The innovations that included were improved extraction process, less use of metal mordants, introduction of enzymes in dyeing, use of biomordants, innovative method for dyeing, optimization of dyeing process. So, these were the main line of action. We planned our technology in a manner whether we can we can bring about any improvement in the extraction of the natural dye, whether there is a possibility to reduce or completely avoid metal mordanting, and in place of that can we use enzymes and biomordants. And just in the previous lecture, I described that we have come up with many cellulases, proteases and other enzymes plus biomordants derived from Pyrus pastia and Urea acuminata, that they can replace metal mordants. Salt, that is what we were using as alum, ferrous sulphate, copper sulphate, potassium dichromate, can we completely avoid the use of that? Then introduction of enzymes, of course, this was done for the first time by us, and then innovative method of dyeing. Can we now, sonicator method of dyeing has now become a very innovative method of dyeing, and overall can we optimize the entire dyeing process? If we can do that, we can really say that yes, we have come up with some innovation, we have an innovative technology. Otherwise, the conventional methods were anyway found to be quite cumbersome. Quality standards of natural dyes. Quality standards of natural dyes vary widely. So, it is necessary to first contact an importer to find out what they are looking for. The problem arises with standardization of the colors, as no two dye lots are identical. Technicians in the pharmacology, food and textile industry loathe this lack of inconsistency. For attempting repeatability of shades of textile dyeing, the recommended procedure, as mentioned in the earlier chapters where we have, or lectures, we have already mentioned certain things. I will still further repeat that it is necessary to practice at least that much. Use of only stainless steel dye baths. You saw that all the dyeing machines which were made for industry are made out of steel. Why? Because any kind of other metal machine or metal made machine can create problems in the dye color or dye extract, and subsequently the dyeing on the fabric. Water hardness was also emphasized in several lectures, because water, if it is not of the proper softness level, will create interferences in the dyeing process, and yarn to water ratio should be 1:20. So, at least these 3 points must be always remembered, be it a laboratory dyeing process or be it an industrial dyeing process. Now, this is a typical jigger machine where we used our natural dyeing process, and you will see that a man is manually rotating the fabric, and the fabric is going into the dye bath, and at the same time the entire process is done in such a fast manner that for a particular time, not too long, the fabric is in the dye bath. So, therefore, and because it is in circulation, the dye. So, as you see that it is an old jigger machine which we try to use for our natural dyeing exercise, and whether it is a new modern jigger machine which we learned yesterday type of a model, or an old machine, in all the case or in both the cases, the adaptability of natural dyeing is facilitated or is shown, and therefore, we try to teach, or we had an awareness program and an demonstration, lecture demonstration of natural dyeing exercise, so that the technologies that were developed in the laboratory could be actually translated to the industry. Similarly, this is a winch machine which was shown for silk dyeing. As I told you, in the winch machine there are 2 wheels, and the cloth is actually wrapped like a rope and then put into the dye bath. There is a dye bath at the bottom, and it was showing very good dyeing results for silk and wool yarn. Economics, when we come to anything, has to be cost effective. This is the bottom line. No industry will take up any innovation if the innovation is very costly. So, we were trying to show them that there is a definitive economic control over these natural dyeing exercises. Dyeing 1 square meter cotton fabric by natural dyes ranges from 6 rupees to 15 rupees, whereas synthetic dyes cost about 4 rupees to 9 rupees. So, for a mere rate enhancement of 2 to 6 rupees, the value addition obtained by the vegetable dyeing or natural dyeing is far more in terms of its ecological and aesthetic value. You see, when it comes to dyeing, the synthetic dyes became popular because they were very cost effective. So, several myths were created, and these myths were that natural dyes are not available, natural dyes are, if they are available, they are very costly. So, we tried to break these myths and we tried to show that that is not the case truly, because we tried to show that 1 square meter cloth, if it is dyed, we bought the dyes from the natural dye producing companies, and we showed that it only ranges from 6 to 15 rupees, whereas for a synthetic dye, the cost for dyeing the same material to the same dye depth was about 4 to 9 rupees. Now, there is a mere enhancement of 2 to 6 rupees, but the value addition that it adds is far more. If we take an example of dyeing a cotton shirt, because these were some items that were regularly produced by the Swaraj Ashram, so we tried to actually show them fabric by fabric or garment by garment, that what is the cost of the natural dyeing process and compare it with the synthetic analog. Dyeing a cotton shirt, which requires about 2.5 meters of cloth, the cost of dyeing is raised by rupees 5 to 10 rupees, which can be sold for 150 rupees in place of a shirt which was initially sold at 75 due to its value addition attributes. So, you see that this kind of cost can be charged more if it is a natural fabric, naturally dyed fabric. There have been many boutiques and many such outlets have come up, which are giving or which are selling only naturally dyed fabric, and they are raising the price because that can increase their profitability. Now, this profitability plus its being non-hazarded, not toxic and non-allergenic is an advantageous attribute of naturally dyed fabric. If we take an example of a silk sari, dyeing a silk sari requires about 5.5 meters of material to be dyed. The cost of dyeing is enhanced by 10 to 20 rupees, and the sari can be sold for triple its original price, that is, if from rupees 500 it can be sold to 1500. A silk sari that was available for 500 or maybe a little more nowadays. When we did this exercise about 5 years back, it is the data from that time, and it can be sold for 1500 rupees. So, almost a threefold enhancement in the profitability can be obtained by using natural dyes, and the cost effectivity has already been worked out. Now, if we just try to make a cost analysis of cotton dyeing with anarka chilka, that is the punica granatum skin, cost of an analysis of a representative dye punica granatum anarka chilka, the cost per kg is about rupees 315, and including 11% tax and so on and so forth, the total cost per kg comes out to be 350 rupees per kg. Utilization of 5% of the rate would be that 17.50%, 17 rupees will be required for dyeing. Additional cost for other chemical processing would be another 250 rupees, 2.5 rupees, and processing charge and all that inclusive will be 15 rupees. All put together will be costing only 35 rupees. For a cloth of GSM 100, 1 kilogram material can actually dye 10 square meters. So, the cost of dyeing of 1 square meter would be like 350 rupees. So, you imagine that the cost enhancement is only 3 rupees 50 paisa, whereas the cloth can be sold for almost double or triple the cost, plus it has its own medicinal and other non-toxic, non-allergic and other benefits. It has a very soothing color, and therefore, it is very acceptable. For a silk saree of 6 meter, the undyed silk saree costs about 900 rupees. Cost of dyeing was worked out to be 21 rupees, and the total cost that was spent on the dyeing process of a silk saree was almost like 921. But the market selling price of this naturally dyed saree was above 1650 rupees. So, there was a total additional value addition of 79 to 80% on the same material, and this is a big gain, because if we try to look at the cost analysis, so has the innovation, has the introduction of natural dyes into the market really made any impact? Yes, it has, and that is the reason why so many boutiques, so many outlets with naturally dyed fabric only are coming up, and they sell their goods like hot cakes. So, it is because there is a demand in the market, there is also the the producers are prompted to meet this demand. If there was no demand in the market, these outlets would be just sitting with their stuff and it won't be sold for this price. People are ready to buy these prices simply because they have understood the usefulness of natural dyes and natural dyed fabric. It is not that the resurgence or the revival has come only because of the German ban and the Indian ban. It is because the market now needs a substitute for these dangerous toxic synthetic dyes, and this alternative of natural dyes has really brought about a real renaissance in the dyeing industry. When we tried to do this innovation work, we tried to put it in the book form, Process Development of Vegetable Dyeing, and we produced this document primarily for the Khadi and Gramodyog village industries, and the book has been submitted to KVIC. Similarly, we shot a video of the entire processing and we submitted it to the Khadi process, Khadi Gramodyog Commission, and this film was known as Process Development of Vegetable Dyes, which was shot during the demonstration that was held in Swaraj Ashram, and it was developed by Feet Lab IIT Kanpur. Now, when we try to look at the various pure natural fabric, that is cotton, silk and wool, silk dyeing with different newer mixtures of natural dye sources was specially developed for Khadi garment industries, because it was found that many new hue colors can be offered. Now, the problem with switching over from synthetic to natural was mainly the color gamuts that the synthetic dyes offer, and so if we can mix and match several dyes in the same dye bath, or we can do subsequent dyeing with different dyes, it can create a huge number of colors and shades, and therefore, it will be accepted. So, as you would recall that in one of the lectures I gave you certain recipes, and those recipes can be further repeated or more permutation combinations can be carried out, so that these dyes can be accepted for many color generation. Cotton dyeing the same way with new combination of natural dyes for cotton, kota and chicken embroidery was also popularized. We have done one full exercise with chicken embroidery people, and we tried to show, because in this sector it was only synthetic dyes. They were using only synthetic dyes for dyeing the fabric, they were using synthetic dyed yarn for embroidery. We tried to show that if we can bring in naturally dyed yarn for embroidery and further naturally dye the fabric, it will be definitely having again more value addition and it will fetch them more money. So, eventually these innovations which are developed in the laboratory are actually meant for the industry. It is not that we do research for the sake of doing research. It is a research for bringing in new innovation in the existing technology, and in the existing technology there was a need felt that the synthetic dyes should now be eliminated, and in order to do that we tried to bring in natural dyes and a variety of colors were offered, but still there is a scope of more and more and more color generation by mix and match method. So, whether it is silk or whether it is cotton or whether it is wool, it is possible to do this mixing of colors, re-dyeing, over-dyeing and all other possibilities are there with natural dyes. Usage of new natural dyes. Newer dyes developed were used for dyeing silk and cotton primarily because this was what was being marketed more popularly. Wool dyes were less shown or demonstrated. Different pre-treatments and modern for better fastness properties of the fabrics for wool, silk and cotton was shown and practiced. Development of innovative dyeing of wool for commercial use in the carpet industry was also demonstrated. We then started to focus our innovation towards carpet industry. There is a very big market, not only domestic market, but international market for carpet industry, and therefore, and because they use only wool and there was a market which was demanding naturally dyed wool carpets. Therefore, we started working on dyeing of different shades of wool and then giving it to the carpet industry for doing the knotting, and they were able to use this, and that also created a niche market for them and got them very good pricing, because after all if the synthetic dyes have to be replaced and if this is cost effective, only then it will, natural dyes will be accepted in the market. Preparation of almost like 16 dyed fabric for the development of different colors were offered to the Khadi Gramodyog Commission, because they wanted that, okay, if you have some technology, why don't you demonstrate it in our organizations? And at several places this awareness program and demonstration and lectures were held to show that in their existing machinery system we can still do natural dyeing. Another factor that we did not want them to understand that it is going to be costing them anything. So, we did it free of cost and in their existing machine. No new machinery was bought. We tried to use our technology in their existing machinery system. I just showed you that on the jigger, the existing age old jigger was used for natural dyeing. Now, the places where betterment was required in this whole industrial process was, it was considered that the extraction process is very tedious. So, low color value and long dyeing time, higher cost of dyeing, etc., were the general problems that the people were facing from the existing knowledge that they had. So, they felt that there is a need for betterment in these area, that the extraction process should be improved, the color value should increase and the long hours of conventional dyeing should be reduced to shorter dyeing period. Therefore, the cost will come down automatically, and then of course, the use of metamodern has to be avoided for the simple reason that these metals, after all, when they are used in the dye bath, the dye effluent then has lot of dye as well as metal mordant, which is run out of the factory either into the water bodies or into the rivers or into the ponds or into the agricultural land. Now, this creates a lot of ecological problem, environmental problem, because it is bulk and bulk of water that is being run out. It is not just 1 or 2 or 4 liters. So, that is the reason if the metal mordant use can be avoided, it is better. But if one has to use metal mordant, then use safe mordants like alum, ferrous sulphate, and at the most stannous or stannic. But definitely if one is using copper or chromium, then one should use only 1 to 2% for if that shade requirement is there, because they give unique shades, there is no doubt about it. With the same dye extract, the shade obtained with copper and the shade obtained with chromium mordant is definitely very attractive. So, if it can be avoided, it should be avoided, and in place of that either biomordants should be used or enzymes should be used. So, frequently used metal mordants like iron, aluminum, copper, lead and tin should be avoided. If at all it has to be used, using these metal mordants have ecological constraints as they generate polluted effluent from the dye bath. I have just explained to you that why this should be avoided, and if we are avoiding this, we really cannot completely avoid it. Why? Because this metal has a very vital and mandatory role. So, it has to be supplemented or replaced by biomordants, which we learnt about them in the previous lecture, that Pastia, Pyrus pastia and Urea acuminata had copper and aluminum respectively in very desired small quantity, just sufficient for the fabric interaction. So, these measurements should be taken into account for the betterment. Why there was a need for betterment, better process? Traditional dyeing process, enormous amount of heat is consumed in terms of heating the dye bath to obtain the desired color, and heat sensitive dyes cannot be used in conventional dyeing. Prolonged heating decomposes the dye molecules. Dye uptake by the fabric is also far from exhaustion, as well as a result fair amount of dye is wasted in traditional methods. So, there were very serious problems of the traditional methods, and that is why it was not popularizing. So, we tried to look at the problem one by one, and we tried to tackle and find an alternative which could be an acceptable alternative by the industry, because most of these jiggers, you saw the machine of the jigger, which was an open machine. Now, so much of steam is being wasted. Now, the jigger machines that are being made out of stainless steel are all very compact. A compact machine then keeps the steam within the body of the machine, and therefore, the dye uptake and the heat exchange is not wasted. So, it is a energy intensive machine that is being now manufactured, but the traditional open jiggers were not energy efficient machines. So, therefore, continuous heating was required. If continuous heating is required, continuous fuel is required, and so on. And also, the temperatures that were attained in this jiggers were of the boiling point of water, and many heat sensitive dyes would decompose. So, it was not necessary to heat. You see that we reduce the temperature in the sonicator dyeing from 80 degrees to 40 degrees. So, obviously, the reduction in temperature has not caused any deterioration in dyeing process. On the other hand, it has enhanced the dyeing process, it has helped in better dye adherence, and that is why it is so acceptable. So, if we are offering an innovative technology, then the technology must have an advantageous situation, otherwise the technology will not be acceptable to the industry. Also, whether the dye uptake is the final and most important thing, is enhanced or not. We can do any kind of dyeing, be it conventional dyeing, be it microwave dyeing, be it sonicator dyeing, be it X dyeing, be it hang dyeing, be it arm dyeing. The ultimate motto is whether dye is being uptaken by the fabric and what is the dye strength or the color strength or the K by S value. If it is improving by any method, that method will be acceptable if it is cost effective, energy effective and time effective. So, you see there are many parameters which go hand in hand till it is accepted, and the traditional methods definitely had a serious drawback. So, therefore, there was the need for better processes to be brought about in the market. For successful use of natural dyes, we need to do the following: reinvestigate and rebuild the traditional dyeing processes, adopt appropriate and standardized dyeing techniques which should be based on scientific studies like dyeing methods, dyeing process variables, dyeing kinetics and compatibility of selected natural dyes. Now, obviously, if we have to introduce a new technology, we must first understand the drawbacks of the traditional technology and then see where are we losing out. Are we losing out on the cost? Are we losing out on the energy? Are we losing out on the time part? If these are the main criteria, then to adapt a new technology, we have to keep in mind to take care of these problems, and very scientifically we need to modify the dyeing method, the dyeing process variables, whether we can reduce the steps as what we saw in the preparation of cloth chapter, that by merely bringing down the steps we can save time and energy and cost, and then see how we can improve the dyeing kinetics by using some more agitation methods which are doable and cost effective, because we cannot bring in something which is very costly, it will not be acceptable to the market. And finally, it should be like, it should have a compatibility, that natural dye should remain in its best form during the dyeing process, there should not be any deterioration. The novelties of the work that we have now produced for the industry are the following: use of newer natural dyes, we have introduced new hue colors with many plants of course, but to name a few, 4 plants: Hibiscus mutabilis, Eclipta alba, Rubia cordifolia, Carnatia carnosa have been shown that good dye extraction was possible and good dye yield was possible. Hibiscus mutabilis and Carnatia were used for the first time. Use of biomordants obtained from plant material and selected enzyme in place of metal mordants to prevent the toxic effect of the metal ions was also shown. Enzymes used were cellulase, protease, trypsin and plant material like Urea acuminata and Pyrus pastia as biomordants was also demonstrated for cotton, silk and wool. Introduction of new techniques of drying, that is ultrasonication. Although we also tried microwave, but we made a comparative data and we found that microwave is not feasible for very large pieces of cloth. So, therefore, for industry it was the ultrasonication which has given encouraging results with respect to dye uptake capacity as compared to conventional dyeing methods. So, we have proven time and again that this is now ready technology for dissemination, and we have even disseminated the technology at several places to show its utility and its advantageous situation. To make the whole dyeing process biosustainable and more eco-friendly, we have shown that by the use of enzymes, by the use of biomodants, by the use of complete replacement of these metal mordants wherever possible, we have shown that the whole process can be biosustainable as well as it is more eco-friendly, because all the components that are used are biodegradable. The overall idea to develop a cheaper and greener process using enzymes and biomodants in dyeing with natural resources and optimization of different parameters for this kind of study to increase brightness and color depth on every kind of fabric. We have shown that it was a myth that natural dyes are very dull, they are not really appealing, but we have brought about very many bright colors. We have brought about that the finished good or the finished fabric can not only be applied on cotton or silk or wool, but it is like an overview. If you see, it is a complete package which shows that extraction, modification in extraction, modification in dyeing, modification in using different pre-treatments, and even the dye fixers that we have used, we have developed indigenously, and we have shown that it has really worked very well in terms of its application, because the bottom line is that the product should be of consumers' interest. If we make anything which is very exorbitant in price, consumer will not buy. If we make something which is not acceptable to the consumer, consumer will not buy. So, we have tried to develop these technologies in order to keep in mind the consumer and its demand. If we have to just look at a general strategy of the natural dyeing work, we will see that we have programmed it in such a way that natural dye extract, if once it is taken out, the aqueous extract is used for dyeing. The aqueous extract is then taken for optical density measurements and even for other tests like finding out whether flavonoids and anthocyanins are present or not, and then subsequently the aqueous extract is then used for dyeing by after doing the washing of the fabric, the tannic acid treatment, mordanting. Mordanting, we tried out both the pre-mordanting and the simultaneous mordanting by reducing the number of steps and so on and so forth. So, this is an overview, general overview of the general strategy that we followed with our natural dyeing work.